हाँ ठीक है, मैं खोलता हूँ। अभी देखो आवाज जा रही है क्या? अभी जा रही है।
Very good afternoon to you all. So we
Hello.
have today with our
Hello.
guest lecturer. Hello, you are audible, sir. Hello.
Hello.
आपकी आवाज आ रही है?
Hello. हेलो
हेलो, आवाज आ रही है सर? You are audible to us.
हाँ, मेरी आवाज जा रही है आपके पास?
हाँ, आपकी आवाज आ रही है, हमारे पास पहुंच नहीं रही है।
आपकी आवाज मेरे पास नहीं आ रही है।
मैं बोल रहा हूँ पर आपकी आवाज मेरी आवाज नहीं आ रही।
ओके, अभी मैं तो आपकी आवाज नहीं आ रही है।
हाँ,
वही बात हो रही है।
हाँ,
रुक
जाओ, मैं एक बार देख माइक्रोफोन किसी का लाता हूँ।
Please wait. हेलो।
हाँ, अभी आवाज आ रही है आपकी?
आ रही है ना? ठीक है सर।
यस, अभी आवाज आ रही है। Hello.
Good afternoon all. So we have today Dr. Bipin Kumar with us. He will guide us regarding our irrigation topic. On behalf of organizing committee, I welcome Dr. Bipin sir on this 21 days tutorial classes on JRF, SRF, ARS and NET exam preparation. I request Mr. Gule to introduce our today's speaker.
Okay, good afternoon to all. On behalf of Agriculture Extension and Communication Department, PJIMPKV Rauri. My name is Nana Sahib Shahdev Ghule, PhD Scholar Department of Agronomy, PJIMPKV Rauri. So today we have with us Dr. Bipin Kumar sir. Very welcome you sir on behalf of Agriculture Extension and Communication Department, PJIMPKV Rauri. This is my great privilege to introduce our today's guest, but I think there is no need to introduce our today's guest. But I think sir has a very great personality. Dr. Bipin Kumar sir, because he is a very famous personality in all of ICR aspirants for his work and great effort for the
Thank you.
ICR aspirants. Vipin Kumar sir, currently working as a ARS scientist at Water Technology Center, IIR, New Delhi, since 2015. Sir has completed his BSc Agriculture degree program from NDUAT and MSc and PhD in Agronomy at IIR, New Delhi. Sir has received a first prize on his article as well as the best paper award. He published about 12 research papers. Sir currently handling two long durational project, that is the integrated crop and resource management for enhanced productivity and profitability. And another one is precision farming for enhancing input use efficiency, which are funding by IIR New Delhi. He is also handling one short durational project, that is the expansion of activities of Biotech Kisan Hub at ICR, funding by DST. So welcome once again, sir. And after this brief introduction, I would like to invite you for giving your valuable guidance. Thank you, sir.
So
Welcome.
thank you very much for giving such a very nice introduction about me. And I hope, as you are expecting from me, I will try to convey the knowledge from my side to make the topics more enriched to you and more beneficial to you all. So first of all, good afternoon, and thank you very much for giving this opportunity. So आप जरा डिसेबल कर रखे हो, आप इनेबल कर दो, आप वो करने के लिए, शेयर करने के लिए. आई थिंक आपका डिसेबल है.
प्लीज मेक द चेंजेस.
डिसेबल कर रखे हो आप, तो आई कैन शेयर इट.
Yes, sir. Now you can share, sir.
Okay,
Please.
thank you. My slides is visible?
Yes, sir. Yes, sir.
Okay. So thank you one and all once again. And the first topic, first lecture, because this is a 2 hours lecture, and the first hour we will consider that a one topic for all. So under the first lecture, water management lecture first, we will discuss about the principle of irrigation, water resource of India, and irrigation development in India. So this would be our major topic under that. So irrigation, I hope here most of the students are MSc and PhD, na? I think here.
Yes.
Yeah, no BSc, na? Not BSc.
Some of the students are from last year BSc also.
Acha, 4th year BSc. Okay. So because understanding the audience is also very important, na, to convey the knowledge.
Yes,
so,
yes, definitely.
Because it is a principle, so we must have to understand what is the irrigation. This is not a new term for you, and you may be knowing this term since your BSc program, you are even before that BSc program. Simply irrigation, why you are going to give the irrigation? If someone asks you, and what is the irrigation? So you must have very clear-cut idea. Actually, what happened when you will go for the crop production? So crop having its own need for the crop water requirement during the life cycle. So from where the water will come? Either it will come from the soil, or it will come from if the water is available on the surface, or in the form of precipitation. So sometime what happened, the water that are available naturally over the surface is not sufficient to meet the water demand of the crop. So in that case, what we do, we apply artificial application of water to the crop root zone to meet the consumptive use which cannot be provided by the rainfall. As naturally, if we see, as I told you, that the supply of the water is main source is the rainfall, because ultimately when the rainfall happen, yeah, I can say the precipitation is somewhat wider term. Can anyone tell what is the difference between the precipitation and rainfall from here?
Yeah, you
No.
can unmute and
if because the class would be interactive, because if one side I will speak and you will listen, sometimes you will feel boring. So try to make the classes as a interactive, so that will be very beneficial, and it will expand your mind. So try to interact with me in between also if I ask anything. If you are not knowing, then no issue. It is not
Mute and speak.
under. So no doubt, leave it. Rainfall is the part of your precipitation. If we talk about the precipitation, under the precipitation, you may see snow, hail, dew. These are the kind of precipitation. Okay, and of that, among that, rainfall is also one of that. So majority of that we receive the water in the form of rainfall. So the amount of water that are not supplied by the rainfall or soil moisture storage, so artificially the amount of water we will apply to compensate that need of the crop is called irrigation. So therefore the need of irrigation is as follow, where rainfall is not sufficient to supply the crop water need, as I told you, where the rainfall is not uniformly distributed to supplement the crop water requirement. Rainfall intensity is not very much important for the agriculture points of view. The distribution of the rainfall throughout the crop life cycle is very important. If the rainfall is distributed across the crop life cycle uniformly, then you need not to apply the irrigation. But if it is not uniform, then in that case, if I'm talking in the case of rain-fed agriculture, do you know what is the rain-fed agriculture? Rain-fed agriculture is the agriculture crop grown only depend on rainfall. Only depend on rainfall. So this type of the agriculture, rain-fed agriculture, is possible when the rainfall is distributed across the crop very uniformly. And third is if there is a variable crop water requirement. So in that case also, suppose your rainfall happened only 60 mm and the requirement is more than that. So in that case also you need to apply the water in the form of irrigation. Because it is a principle, then we must know about the some 1 minute. Are you seeing this? What is written here? Supplemental irrigation. Maybe because something icons are fitted here, so that's why maybe it is not visible. That's why I'm thinking. Is it visible?
Yes,
Supplemental
yes,
irrigation?
yes,
Yeah,
yes,
so no issue. So I was talking about the irrigation. So what is the supplemental irrigation? I told you before that some of the area in our country or even the whole world that are rain-fed, means the farming system, agriculture totally depend on the rainfall. So in that case, what happened? You can see here the supplemental irrigation, how this irrigation play a role there. Supplemental irrigations can be defined as the addition of a small amount of water to the essentially rain-fed crop during the times when rainfall failed to provide sufficient moisture for normal plant growth. So the purpose is to improve and stabilize the yield. If suppose some of the area where the you are growing the crop as a rain-fed, so sometime I told you that when the rainfall not happen, and if you are considering that if you are not applying the water at that time, your crop may suffer use. Maybe crop losses happen. So in that case, the amount of water you will apply in rain-fed condition, that irrigation is called supplemental irrigation. So you can see here the picture on the same area, same time of the sowing, but only the difference, in this case, the farmers applied supplemental irrigation, and in this case, not applied supplemental irrigation. So you can see here, this is having high greenness and still it is in growing condition. And this area is facing the problem of forced maturity. Forced maturity. So this type of the problem we can avoid, and we can enhance our yield, stabilize yield by this simple a small amount of the water application at that time. That is called actually the supplemental irrigation. Supplementary in the area limited water resources based on the following three premises. जैसे कि the water is applied to rainfed crop which would normally produce some yield without irrigation. Since precipitation is the principal source of the moisture for rain-fed crops, as I told you, supplemental irrigation is the only applied when the precipitation fails to provide essential moisture for improved and stabilized production. Okay, and the amount and timing of supplemental irrigation are not scheduled to provide moisture stress-free condition throughout the growing season, but to ensure the minimum amount of water required for optimal yield available during the critical stage of the crop growth. The purpose of main objective of the supplemental irrigation is to provide the moisture at the time of when the crop faces use. The crop is more sensitive during that phases. So the objective of the supplemental irrigation is to provide the moisture satisfactorily during that time. The objective is not to provide moisture throughout the growing season. Okay now, so this is the somewhat differences in between the irrigation and supplemental irrigation. Now we can talk about the another, that is deficit irrigation. So deficit irrigation is the optimization strategy in which irrigation is applied during drought sensitive growth stage of crop. Okay, this is also similar to the supplemental irrigation, but this irrigation you can we can pronounce deficit irrigation in the case of irrigated condition also, but supplemental irrigation always we used to pronounce in the case of rain-fed agriculture. Okay, outside this period irrigation is limited or even unnecessary if the rainfall provides a minimum supply of water. So deficit irrigation sometimes what happen, it not necessarily if the minimum amount of the moisture are applied by the rainfall. Water restriction is limited to drought tolerant phenological stages, often the vegetative stage and the late ripening period. If you see the crop life cycle, there is three most important phases. First is the vegetative. Second, you can say reproductive, and after that ripening. So the purpose of deficit irrigation we always pronounce are used to apply when during when the crop are more sensitive to the moisture. Okay, so at that case we used to apply, and here what is saying that those phenological stage means vegetative stage and ripening stage. In this case, the water restriction is limited to drought tolerant phenological stage, often the vegetative stage and late ripening stages. So even we can restrict the some amount of, we can compromise during this phase, but we cannot compromise the water during this phase because these two phenological phases drought tolerant. Okay now, and this is the most sensitive. So we always use these terms, especially deficit irrigation. If your water is limited, so in that case you must apply the water during this phase. So that is actually called your deficit irrigation. And after that, the one because this is the different terms related to the irrigation we discuss here. Now we will talk about the irrigation planning. If you are interested to plan irrigation in your area or at a farm, or anyone if asking to make the plan of irrigation, so what are the tasks you need to do? The first of all, you need to do requirement of water and ET crop coefficient. You must have to know. Then accordingly you can decide the type of irrigation. Then irrigation frequency you need to calculate, and then limitation of selection of irrigation system. If you are selecting some irrigation systems, either drip irrigation, sprinkler irrigation, or maybe surface irrigation, so you also have to understand what may be the limitation of that. So that problems you must also have in your mind. If suppose you are going to face that kind of the problem, so you need to be very ready for preparedness. Design parameter like site spacing, application pattern, limitations of design, as I told you, advantage and disadvantage each irrigation system, and pumping requirement. So these are the some of the tasks you need to do when you are going to plan for the irrigation system. Now you must have to understand, because this is the principle of the irrigation, so what functions that irrigation will play. So here you can see irrigation actually supply the moisture to the soil, essential for germination of seed and various growth processes of the crop. Two things are very important. One is the germination. If the soil is not having sufficient moisture, at that time what will happen? The proper plant population you will not achieve. So if once the plant population are not achieved, then at the time of sowing only, or after 10 or 15 days, 10 or 15 days, you know that on the basis of the plant population, you are defined at that moment of the time that you will not get a proper production from a unit area. So that is why at the time moisture is very essential. So that is why the pre-sowing irrigation is very much required for the, if you want to achieve a uniform germination. After that, when once the crop germinated, then it will definitely go different stages. So during that stages also, they will require the water for the physiological function, biochemical functions. Okay. Second, the cool the soil and its surrounding, thus making the environment more favorable for the crops. So always you may heard that field have its own microclimate. Its own microclimate. When you will go around the field, and if you compare the temperature outside and inside, so you will find differences in temperature, especially temperature. Okay, so why it is happen so? Because that type of the crops, they require their own environment, and that is why where the moisture play a very important role to minimize or to maximize. If it is a hot condition, so cooling is required. If it is too cold condition, so in that case also irrigation play a very important role for increasing the temperature in that area. You might have been heard about the frost. So in the case of the frost happen, farmers are advised to apply the irrigation in their field so that they can compensate, they can reduce the losses that may happen because of the frost. So this is also one of the function. Washes out or dilute the salt present in the soil. So it is if you are growing again, because agriculture is an intensive input application process. You will apply the fertilizer, pesticide, insecticide over this field again and again when you will take the crop. So what will happen? Even the fertilizer, even the simultaneously, sometime the salt also come blown by the wind and runoff. So they may go over your field. So if when you will apply the irrigation, that irrigation water also dilute that salt, and that will go leach out beyond your root zone. So salinity will not develop in your field. If you see in the case of Haryana or in Punjab, these two areas most frequently irrigated by the canal only. So because of the canal irrigation, that causes what? Salinity development, because canal water will have more salts as compared to the pumped water. Okay, now, so if it is happening, it is kind of the case, you may go for the leaching of the salt by the providing the irrigation. So the amount of water that are required to leach out that salt and to make a desirable salt concentration in the field. That is called your leaching requirement of the, okay. Soft the clothes and thus help in tillage operation. Optimum tilth you will get when the moisture, optimum moisture is there. Enables application of the fertilizer. Fertilizer cannot play a role if the proper moisture is not there. Okay, now reduce the adverse effect of the crop on the frost, as I already discussed. Ensure crop success against the salt during salt drought. So yeah, it is always if the droughts happen, salt drought happen in that period, so it will ensure your crop. And finally, when this type of the function you will get from the irrigation, so what you will get, crop production will maximum, and it will ensure your food security of your village or your family or your country, and it makes agriculture profitable and competitive. Irrigation improve land productivity and value. Definitely you will get more production per unit area. Promote employment generation and livelihood security. Main conveyance irrigation canal can be used for flood protection and recreation and navigation. Apart from that, if you are government is doing some canal development, so that canal construction will help you to protect from the flood, as well as that site can be used for the recreation and navigation. It promotes fishes and wildlife conservation. Rapid development of irrigation facility through construction of multi-purpose dam enhances the hydroelectric power generation. These are the some of the area that are also associated with the your irrigation development. So that is why when you will see at the time of the green revolution, many dams are constructed. So we will discuss that part also in the later phase, the irrigation development after independence. So that we will discuss. So that is other sector is also very much related to your irrigation development. Irrigation promote whole area of agro-based industry, which are driven in engines of the economy. As we know that our Indian economy is the agrarian economy. So overall, if the agriculture industry will grow, so that will be overall our economy will grow. After that, this was about the irrigation types and the some of the, because this is the principal class. Now we will understand what is the water potential. So if we go, because we understand what is the function, what advantages you will achieve, and what is the irrigation, and their related terminology. Now we have to understand what is the water potential also, because if you are not understanding the water potential, then you cannot manage irrigation very efficiently, because water potential is having very important role for the movement of the water across the hydrological cycle, even in the your field. So under the normal condition, the water potential in the soil is higher than the in the root, shape, and floods. Why it happens so, I will tell you. Water potential in the soil, you will always find the negative value, and there is role. When if the negative potential will be not there, then movement of water will not happen. That is why you may see here the typical soil moisture have a water potential of -0.3 to 1 bar. This is the actually the value under that the water available. Those are become the those we usually say that soil moisture. In the root system, if you see, the water potential is -4 bar, and in stem 7 bar. In leaf system, you may see that 10 -10 and to 12 bar, and dry atmosphere have 400 to 600 bar. So what picture it is showing, why it is happening so, and why the need of this kind of the variation in water potential in soil, plant, and atmospheric system. You may heard the terms soil, plant, atmospheric continuum. Maybe if you are a agronomist, you are doing MSc in agronomy, or if you are doing PhD in agronomy, and if you are still aspiring for the JRF to prepare for the JRF, so this term is very important. You must have to understand. Actually, the soil plant atmospheric continuum means how the waters, they are moving from soil to plant and atmospheric, and then again it is coming back. So the water movement through this system, we usually used to say that soil plant atmospheric continuum. Here I told you that soil is having, you can see 0.3 to 1 bar. So this is having somewhat higher potential. If you are seeing, if suppose I draw a root here, and this is leaf, and this is your stem. So in the root, in the soil 0.3 to 1 bar minus. Always you have to understand that the water potential is maximally in the case of soil water potential, it is always in negative. So minus 0.3 to 1 bar in the soil. In the root, it is written minus 4 bar. In the stem, it is minus 7 bar. In leaf, you can see here about minus 10 bar, and in atmosphere it is minus 402. So you can see here water always flow from the high water potential to low water potential, and here it is case found that high water potential. So that's why water will start to move to the root system, and when it reaches to root, then it found that in stem system there is a again negative potential minus 7 bar. So it will go to the stem. Then it found that when it reaches to stem, then it found that leaf is having always again a gradient, lesser water potential. So it will reach to the leaf, and it is influenced by the atmosphere. Atmosphere is dry, and that is also having the lower atmospheric water potential. What I told you, that minus 400 bar. So it will leave this leaf, and it will vaporize, and it become the part of atmosphere. And again it will, when it reaches over the some altitude, then it will condense, and again it become the part of rainfall, and it will become the part of soil moisture. So this is, you can see here how it is playing the role. Because of this water potential, water is continuously moving in our system. Why? The physics playing very important role. This water potential is the part of the physics, soil physics. So a very important points, that is the water potential, that's why it is written here. This difference in the water potential, hence the potential gradient of the driving force for the causing water always in the movement condition. And why the rainfall, as you know, when it will condense here, so because of the high altitude, gravity will be working here. So because of the gravity, automatically water will start to fall above this soil. So here you can see soil water potential is the sum of solute potential, pressure potential, metric potential, and gravitational potential. So G, this G is the component of rainfall. And even I can say that when this water is at surface, so again there will be a force working over that is called gravity. Gravity. So that is a gravity, it will go percolate, and it will become the part of soil storage. Soil water storage means reservoir, it will recharge and become the part of aquifer. Okay. So here you can see water potential, the potential energy of water per unit volume of pure water in reference condition, and very often is represented by the psi, Greek letter. And water potential quantify the tendency of water to move from one area to another area. If I compare the highest water, when we will say that water potential is maximum. When the water is pure, there is no any external forces over that. So at that moment, the highest water potential is 0. Okay, this is your highest water potential, and it's happen when your water is pure. Okay, so pure water is having highest water potential, and soil water potential, if we are the water potential we are talking, so under the water potential there is many component, four major component like solute, osmotic potential, pressure potential, metric, and gravitational potential. Now we will see here with the help of one of the example here, through the help of osmosis we will understand the osmotic potential. This side is pure water. You can see this side is a pure water. So definitely this side will have highest water potential, and that will be equal to 0. Here I have written. This side you might have been seeing here different solute. These are the solute, this side, and these all solutes are separated by semi-permeable membrane. One membrane is here. Because of that semi-permeable membrane, these solutes are not able to reach this side. That is why this side water is pure. And when the solute will be this side, then definitely the water potential will be lower this side. But how much? This would be the question. If you added this quantity of the solute this side in a solvent or in water, we can say, so definitely there will be the negative potential in this side, but the question will be how much. So for that estimation you need to go for this experiment, and you can see here, suppose you did like that. So in natural condition what will happen, you can see here, automatically what you will see, the water will start to recede from here and water will increase this side. You might have been seen in this animation. Automatically what happened, this is called osmosis, means high water potential to lower water potential is water will start to move and it will rises the water table up to here. When it will be stopped, when the both side potential will be equilibrate. So here is the how much it is negative. That is why this absorbs the water. For that estimation, you need to apply the external force. Now I am applying the external force from this side. You can see here, and again with the help of this external force, now I equalize the table both sides. Now water table is equal both sides. So the amount of energy we applied in the form of force, suppose I applied 5 bar, the force to equalize the water table in the both side. It means that here is the minus 5 bar water potential. Okay, because I need 5 bar as an external force to equilibrate both sides. So through that, this is the reverse osmosis. Through this reverse osmosis, the amount of energy you applied over that to equilibrate that water table both sides, that is through that you can calculate the what is the water potential of this side. So this is the example of reverse osmosis, and that their role was mainly playing osmotic potential. Why the osmotic potential? How the osmotic the solutes lower down the water potential. Suppose this is pure water. This is the glass, and we are having only H2O. Nothing else are contaminated. Okay. Now we will add the solute. Suppose we add the solute sodium chloride in this water. So you may see that when we dissolve the sodium chloride, so what will happen? It separate the two water molecules, and that sodium will bind one molecules and chlorine will bind the another water molecules. And why it is happen? Because water we have bipolar in nature, minus and negative both charges are there. So because of this property, you can see that there will be the breakdown of the water molecules itself. So once again and again you will add more and more sodium chloride. Suppose I am giving the example, means solute you are adding. Because of this increment of this distance between the two water molecules will be increased more and more, and then it will lower down the water potential of your this pure glass. Previously it was totally pure, no solute. So at that time it was having 0, and 0 means maximum water potential. When we start to add this solute from outside, so this process, because of the splitting of the two water molecules, will happen. And again when we will add, so many water molecules split, and there will be two gap in between the two water molecules. So because of these principles, that will lower down the water potential of this class. Now I will show you what is the metric potential. In the field, you might be see the different type of the texture classes. They will have the different surface area. Surface area. If suppose the soil is sandy, that will have less surface area, and if it is a clay, then it will be having more surface area. So how surface area is playing the role? The surface area that will play important role as a capillary potential. We can say the capillary potential. Because of this surface exposure, water will start to move, and that will go and bind to that surface. When the more and more final particle, in that case, metric potential will play major role. So this actually this, when the unlike molecules they will bind, means soil surface, if it is binding with the water is binding with the soil surface, that forces there will be one force that we will call adhesive force, and water to water they will bind together, that is called cohesive force. And if you see when you apply the water in the field, in that cases when the water is your totally saturated, means you applied the water, now you irrigated and stop. So after application of the water, means irrigation, you will find that your all pores are filled with macro or micro, both are filled with the water. So that state we call as a saturated state. Okay, na? So how the gravity will start to play a role, you can see here. Here you can see the water are, suppose you irrigated right now 100% pores are filled. Okay, so when the totally it is filled, the moment we call it as a water potential of that soil, saturated soil, will be 0. When it achieve, after immediately what will happen, G will start, gravity will play the role, because you apply the water at the surface of the soil. So gravity will start to play, because we always feel gravity over the soil surface. So the water, those are bind here. Here are the adhesive forces, and these are the cohesive forces. So you can see when the gravity will start to play the role, you may see that gravity can extract the water up to -0.3 bar. Okay, when it reaches -0.3 bar, at that point G will not play a role. Okay, after that, and in between -15 bar, this is actually the water, those are available for plant. So that's why we always call this is the available zone. This water will be actually absorbed by the plant, and those are very finely attached with the soil surface. Means your matrix potential will play very important role here. So these water are not absorbed by the plant. So when it crosses above, below that, when energy lower down, means while water potential go again more negative, because when it will very close to the soil surface, it means that at that point your matrix potential will be very high. So that water cannot be absorbed by the plant. So that is why minus 15 bar onward, plant is start to show what? Wilting point. Okay, and it reaches when it is totally closer to this, the water we used to used to say that the hygroscopic water. And pressure potential is positive. The potential that is attributed because of your water always exert pressure outside here, but because of the boundary of the cell wall, they also exhibit the pressure inward. That is why your plant attain the proper shape because of this potential. So the external forces, those are applied from the boundary of the cell wall over this your outgoing water molecules is called pressure potential. And what I told you, that is one of the playing major role behind the water to move from soil to plant to atmosphere. And finally, it's make the hydrological very important component, the hydrological cycle. Now we will start to discuss. These were some of the principle we discuss here right now. If you have any queries, you may ask in between that. Hello. Up to so far, if anyone having any confusion, they may ask.
Among participant, if you have any query, you can ask directly to the speaker. Otherwise, you drop your question.
Neither I am going to another topic, that is the water resource development in India.
Okay, sir, you may please proceed. We will see at the end.
Okay. So irrigation development, here you can see the 1951, we were having 16% potential created as a ultimate irrigation potential. And in 2002, the data is here, we are having right now 67% irrigation potential created, we develop. So definitely day by day, we are increasing in the terms of technology, in the terms of infrastructure. So what are the different sources of irrigation sources? Here, major medium irrigation source, you can see 39%, minor, that is 13%, and surface and minor groundwater, we are using 48%. So these are some of the sources of irrigation. So here you can see, according to the plan wise, how we created storage of the water. Here in the pre-plan, means 5-year plan, when it started, 1950-51, the first planning commission happened from 1950-51. So pre-plan, you can see the storage capacity was only 15.6 billion cubic meter. Up to the end of 8th 5-year plan, you can see we created 176.73 billion cubic meter. And then up to the end of 9th, 213. And this is the data up to the 9th. And you can see at that time there was 75.4. This capacity was under the construction. And these were under the planning commission that we will consider to again create the 108 billion cubic meter storage capacity. So definitely you can see here that we are increasing day by day in the terms of our storage capacity. And if you see that water availability in cubic meters availability, how it is starting to decrease. In at the time when the first planning commission 5-year plan developed, at the time we were having the 5,177 cubic meters availability per capita annually, and now we are having only this. So why it is happening? Because if you see the water's demand from the different sector, how many sectors we are having? Majorly here we can see here domestic, irrigation, industry, energy, and after the fifth is the others. Here you can see in right now we are here near about here. So 1990 it is given. Now you can see domestic sector just it double from 1990. Irrigation sector 460, it reaches only 770. Can you tell anyone why it is why it is even it is so far only means use is only increases very slight? Why in this case? What playing important role? In the case domestic, you can see here 25 to it jumps 52, means near about just double. But here this figure cannot able to double. Industry also I can say here many-fold increment in the industry sector. Only it was billion cubic meter, 15 billion cubic meter in industry at the time of 1990, and now we are having about near about 120. So why? Because at the time of 1990, if you see the net irrigated area, sorry, net cultivated area and grass cultivated area, there is no significant increase in the area expansion. Simultaneously, technology wise, we are enhancing, means we are increasing our farm water use efficiency. That is why even though we are intensified our cropping system, okay, right now we are having more than 150% in cropping intensity, and that may be the more than at the time of 1990. The because reason is that now day by day we are adopting the new tools and technology that helps to increase our water use efficiency. That is why simultaneously we are increasing our cropping intensity, even though we are not demanding too much of the water as compared to the domestic and industry. So in domestic cases, why it is happening? So population is increasing very fast. Okay, now so that sector is unstoppable. That is why if you compare the population of 1990 and 2025, so you may see that there may be the gap of near about 40 crores population extra we added in the India. So definitely that sector cannot be stopped. And that and industrial revolution also taken place after the 1990, because at the time you may knowing that Manmohan Singh bring economic reform at that time, and that reform bring too much industrialization. After that, industry grown many fold. So industry also demanded too much of the water. Energy also you can see here, but we are the huge quantity demander. You can see overall our figure is highest in the case of irrigation, because irrigation is prime, you can say, the life of agriculture. If you see the civilization of any country, it started from a river basin, either Nile civilization or Sindhu, or any civilization. If you see that is started from the river only. So that is why, because agriculture without water cannot exist. Okay, so it is highly intensive water demanding sector. So our agriculture sector always have a very huge apprehension for this water scarcity in the future. So source of water, where we will get either in the form of surface, underground, atmospheric, and ocean water. These are the 4 sources where from atmospheric means rainfall. Water resource development in India, you can see here, we are receiving about 1194 mm of the annual water. And if we convert into million hectare meter, so this is about 400 million hectare meter of the water we receive in the form of precipitation. And of that, 75% come from the southwest monsoon. We are having 2 types of the monsoon. One is the southwest monsoon, and second is the northeast monsoon, 25%. So in this, apart from this is from the atmosphere we achieve in the form of rainfall. And here, if we talk about the surface, in the case of surface, so our river system play a very important role for the storage of the water, those are melted from the glacier or fall from the atmosphere, that will be retained over our river system, and that finally it will go to our ocean system. So Indian river system, if you see, one of the very important source. So India is one of the top 5 country in the world with favorable water resource. Those who are the first is the Canada, second is the Brazil, Russia, and Congo. After that, India is the 5th country. Those are having favorable water resource. Among the total water resource of the country, Indian rivers constitute major share. So, and water in this river is used for the various purposes. Say, you can say that agriculture, production of electricity, as I talked that different sectors are having demand, storing water in the dams and so on. So Indian river system, you can divide the Indian river system into 2 types, Himalayan river and peninsular river. So if you draw a map and you see that whole India geographical map, you may see that like veins and arteries in our body, same our map is also having different veins, and that is river system. That is why it is productive, it is producing, it is supporting to the crop, it is supporting to the civilization or settlement of the people. So if we start to talk about the Himalayan river system, so Himalayan river system, these are the names. Always says that Himalaya, Himalaya, it means that rivers those are originated from the Himalaya, that are called as a Himalayan river. So here you can see in the Jhelum, Chenab, Ravi, Satluj, Beas. So these are the name of the Ganga, Brahmaputra. These are some of the name of the rivers those are originated from the Himalaya. And in this, that's why we call the civilization those that happened here, that civilization is called Indus civilization. So in this river system, the sources you can see here, Tibet near Mansarovar Lake, flowing westward and enter India into Ladakh district of Jammu, Kashmir. Okay, and courses of you can see in this, it is flow through the state of Jammu, Kashmir, Himachal Pradesh, and then Punjab in India. Then it enters the Pakistan and flowing forth south reaches the Arabian Sea and east of Karachi. Actually, this Indus river system, some part it is flowing in the India, and some it now become the part of Pakistan. Previously, Pakistan was also the part of our India. So at that time, we were having this. Actually, this Indus rivers, because of this Indus river system, if you see this Indo-Gangetic plain area, Punjab, and side by the Pakistan, these are the very fertile area. That is because of this Indus river. And if you see the tributaries, the name of tributaries like Jaskar, Nubra, Soyak, Hunja are the tributaries in the India, and Ravi, Chenab, Satluj, Jhelum, these are the tributaries in the Pakistan. What do you understand about tributaries? Tributaries means suppose any main river, suppose it is main river, and some other channels or rivers are coming and becoming the part of this main rivers. These all A, B, C, D, E will be the tributaries. These all are feeding to the main, means they are collecting the water from this whole what I can say watershed area, and they are flowing it into the main river system, and then finally it is flowing and going to become in the part of Arabian Sea, and it is becoming, Indus is becoming part of Arabian Sea, where in the east of Karachi. So characteristics, if you see, the slope is very gentle of the Indus, and the length is 2900 kilometer length, and this is the longest river in the world. Now we will talk about the Ganga. So that was actually this Indus river system playing important role both for India as well as for the Pakistan. Now we will talk about the Ganga. In between हम लोग थोड़ा सा 5 मिनट का रेस्ट लेना क्या?
Sure, sir. Sure. No,
हाँ, क्योंकि बोलते बोलते ना 1 घंटा तो हो ही गया, थोड़ा एग्जॉस्ट हो जाता है. अच्छा, इसी बीच में कोई को अगर 10 मिनट ना 5 मिनट में अगर कोई क्वेरीज है, दे में आस्क.
Siddharth Shankar, who is Siddharth Shankar?
किसी को इतने टॉपिक तक किसी को इंटरेक्शन करना है तो कर सकता है, उसके बाद फिर हम स्टार्ट करेंगे.
Yes, yes. Due to efficient irrigation. Anybody from class want to ask something? They can.
कोई आप नाम लो किसी लड़के का, देखते हैं इसमें से कोई लाइव है सब या सब ऐसे ही खोल के बैठ गए हैं. कोमल साहब ने, कुणाल साहब ने, कुणाल
गावंडे,
कोमल साहब ने, कुणाल गोंदे.
गावंडे. Kunal, you want to ask something?
Are you listening me?
Please unmute yourself.
Mitali.
Yes, sir.
If you want to ask,
Soumya.
you can interact. Hello, Mitali.
Lokesh.
Hello, sir.
Yeah. Just I want to know that you people are listening me, or just made a you joined and that's left it. That's why.
Yes, sir. Yes, sir. I'm listening. Yeah. I want to know the difference between life-saving irrigation and water deficit irrigation, sir. I didn't understand that.
Life-saving irrigation, you can say life-saving irrigation. The purpose of deficit irrigation is just suppose you are having water scarce. Suppose you are having the limitation of your water. You are having suppose the demand is 1000 liter, and you are having only 60 liter of the water. So what you will do? You will provide that water only most critical phase of the crop growth. Okay, na? Because you are having limited water. So actually you are providing the water at most critical stages to save the crop to be it go to fail, and in the form of deficit irrigation means you are applying optimum to suboptimal. Okay, na? This is actually called deficit irrigation when you are having limitation of the water. Life-saving irrigation is also what we used to say mid-season correction, means a type of life-saving irrigation. Suppose in the case of rain-fed, especially we used to pronounce it as in the case of rain-fed. When you are growing the crop and you are knowing that your crop may fail, So sometimes supplemental irrigation, you can say that supplemental irrigation is a life-saving irrigation also, because life-saving, you are saving the life. When you are going to know that your crop may fail if you are not applying the water at that moment of the time. Okay.
Yes, sir. Thank you, sir.
You got my point or not?
Yes, sir. Yes, sir.
And that life-saving irrigation you may create just by harvesting the water. Those are become excess. As I told now, water is not distributed, rainfall is not distributed across the crop growth. Okay, so when
Yes, sir.
you are getting too much peak, so at that time you need to make some arrangement that you can harvest that water, and you may use that water as a life-saving irrigation in the further time. Okay, so some
Okay, sir. Okay,
terms
sir.
are very much confusing, but you must have very clear-cut understanding. Deficit irrigation means you are not applying the just by a fashion. You are you are not able to apply because you are having the limitation.
Yes, sir.
You are understanding now?
Yes, sir.
Because
Yes, sir.
the demand was 1,000, but only you are having 600 or 500 liter. So you will apply that quantity of the water. Those are very sensitive stages in a deficit manner. Okay, na deficit. That's why that is called deficit irrigation.
Yes, sir. Thank you, sir. Thank you, sir.
Okay, welcome. So let's move. Now we'll talk about the Ganga. So Ganga, everyone know that this is the name itself, how holy it is. Ganga, we consider it as a goddess. So Ganga rivers originated in Gangotri glacier. The origin is Gangotri, and glacier as a Bhagirathi. It originated there as a Bhagirathi and joined by Alaknanda at Deoprayag, and it turned into Ganga. So it originated as a Bhagirathi, then joined Alaknanda at Deoprayag, and then it became the Ganga. And if you see the courses, how it's moved, because of this Ganga, you can see whole North India belt is very fertile, one of the highest fertile belt in the world. And this belt is the one of the most important belt for the rice wheat cropping system. That is why it is called the bowl of India, food bowl of India. So courses Ganga rivers enter plains in Haridwar, and from where it is flow eastward and enlarged by the tributaries, as whenever it will go again and again, it's joined by many tributaries. That is why its sizes increases whenever you will go. From left and right, both from both sides. You can see from left and right. And the river divides into West Bengal and distributaries like Hooghly flow southward to reach the Bay of Bengal. The main rivers entered into the Bangladesh and joined the Brahmaputra river. Actually, when it reaches into the West Bengal, it become two part. Ganga joined two distributaries, and one distributaries, as I told you here, in Bengal, it flows as a Hooghly, and it finally reaches to the Bay of Bengal, and the distributary that enter into the Bangladesh, and that join the Brahmaputra. And the Brahmaputra, you know, is coming from Assam, and then it again come into the Bangladesh. So in Bangladesh, it joined to the Brahmaputra. And the name of the tributaries, very important, like the Yamuna, it joined at Allahabad at right bank tributaries. Ghagra, Ganda, Kosi, these are the arising from Nepal, but joining to the Ganga as a tributaries. And you can see sometimes it's the length is always asked in exams, that what is the length of the Ganga. So 25 kilometer it is flowing. And the slope is almost steep in the Himalaya and gentle in the plain. It is when it is in the Himalayan zone, at that time the steep is too much. But when it comes to the plain, Tarai, that is why when it's come and join the plain, the area become the Tarai. And that belt is very fertile for the rice. And water table in that area, if you go, you will find very shallow. So many advantages we are having because of that. And then after that, we'll talk about the Brahmaputra. As I told you that Brahmaputra rivers originated in Tibet Tibet to east of Mansarovar Lake. And if you see the courses from where it moves, Brahmaputra River mostly flow outside India from the point of its origin and the middle of the coast, and it enters Arunachal Pradesh and later into the Assam, and then it flow eastward in Bangladesh. And in Bangladesh, Brahmaputra River is called as Padma. In Bangladesh, we used to pronounce this Brahmaputra. You can see here, this is coming from this side and joining here in Arunachal Pradesh, then Assam, and then finally coming into the Bangladesh, where it is called as a Padma. And this river is actually, if you see, having very high silt, because it is flowing all long route through the mountain area. So steep flow is very high. So that's why it causes too much erosion. Okay. And so if you see the water of this river, you may find huge silt. That means soil particle will be more in that. And tributaries, if you talk, Lohit, Kensula River, these are the tributaries of this, and length is 290. This is longest than the Ganga, but I told you that this is flowing maximum in two countries, in one in even China also, and Bangladesh. Okay. After that, we will talk about the peninsula. In the South India, the main characteristics of the peninsular region, those rivers flow in the peninsular region, they are not, first of all, perennial in nature. They are seasonal. They will flow more when the rainy season, and it will be not flow, you can say, dry out in the case of when the rainy season is stopped. So here you can see these rivers are confined to the peninsular region and are depend on rainfall for water, as I told you. Unlike Himalayan rivers, these rivers are shorter with small basin. Basin will be lesser. Narmada, Tapi, Godavari, Krishna, Kaveri, and Mahanadi are the main rivers of the. So Narmada, you can see this is originated in Amarkantak Hill in Madhya Pradesh and flowing toward the west, join the Arabian Sea. It joined the Arabian Sea and cover the state of two states, Madhya Pradesh, Gujarat. Okay, and Tapi basin, it other rivers is Tapi basin. It rises in Madhya Pradesh and covering the state of Madhya Pradesh, Gujarat, and Maharashtra, and then join again the Arabian Sea. Narmada and Tapi. Here, Godavari basin, you can see here, it is 1500 kilometers long, and we used to say this is the Ganga of South India. And Godavari river originated in Nasik in Maharashtra and covered the state of Madhya Pradesh, Odisha, and Andhra Pradesh, and flowing eastward and join the base of Bay of Bengal. And after that, Krishna basin, you can see it rises near the Mahabaleshwar in Maharashtra and covering the area of 1300 kilometers, is flowing through the Maharashtra, Karnataka, Andhra Pradesh, and then again it reaches to the Bay of Bengal. After that, we talk about the Kaveri. Kaveri is originated in the Western Ghat, and you know the Western Ghat also receives huge amount of the rainfall, and it's covered an area of 760 kilometers and reaches to the Bay of Bengal in Tamil Nadu. And this Kaveri river is having a dispute for the water in between the Tamil Nadu and Karnataka. Many times it has become the part of the news, and two states are very angry each other just because of the water dispute. Okay, and it is flowing, cover the state of Karnataka, Kerala, and Tamil Nadu. Beside the above, the rivers include Mahi, Savarmati, Suvarnaka, Rekha is also come under this peninsula. So these were the surface water and rainfall. We quantified that how much. Now after that, how the irrigation, we'll talk about the irrigation development happened in India. How much time we are having? 47 now?
Yes.
Because already the content you provided me ना, it is too much. अगर उसको हम करेंगे ना तो बहुत टाइम लग जाता है. तो हमने तो बनाया है, देखते हैं कितना 5:30 बजे तक खत्म होता है.
Yes, definitely.
Rest we will do in the next, because continuously speaking 2 hours is also very lengthy, very hectic. Sometimes it's not interested for the student also, and it is very tough to manage by the faculty also. So now we will talk about the irrigation development in India. So here you can see in the Vedic period, 4000 BC, birth of Christ, Atharvaveda mentioned about the design of irrigation system. In our Atharvaveda, Vedic period, there is a mention that there is some literature we found that irrigation was mentioned that time. Okay, the great saga Narada, who came to see Emperor of Yudhishthira around 3150 BC and asked the farmer, "Study and prosperous. Are the farmers are sturdy and prosperous? Are the full of water, and are the dams are full of water? Are big enough so that they can distribute in different part of the kingdom?" So this type of the questions were asked by some of the many those emperor, those ruled at that time, 3150 BC. So this type of the literature, it means that the irrigation development in India is not new. It is started since long back. Okay, and ancient Indian ruler took very keen interest in the construction of irrigation work. The account left by the Megasthenes, the Greek ambassador to the court of Chandragupta, has given an account of irrigation in India is about 300 BC. And Chandragupta is credited with the construction of Sudarshan Lake. You may be knowing that Sudarshan Lake. So the credit to construct gone to the Chandragupta. So after that, you can see some modern large-scale irrigation work also done, maybe began in the 19th century when we entered in the 19th century. Just like the example of the Kaveri Delta system in South India, and construction of Yamuna Canal in North India. These two, when we were under the rule of Britishers. So in the 19th century also, you can see Kaveri Delta system in South India and the Yamuna Canal system in North India. The construction regarding that also started. So Godavari Delta system was undertaken 1846, and Krishna Delta system development started 1851. Means when we are approaching to the 19th century. And Sir Professor Kathi and Sir Arthur Cotton were the leader. He was the leader who led the foundation of modern irrigation engineering in India. Kathi's finest work is equated over the Solani rivers. He was also responsible for the Great Ganga Canal and the upper and cut across the Kolarun and branch of the Kaveri River. So he was the engineer who constructed these basins, and he developed Godavari and Krishna Delta. And here, I think I missed some of the major work. 1 minute. One table was I think I shown before that. Leave it. So after that, after the independence, you can see how much work has been done for the irrigation schemes like Bhakra Nangal, dams we constructed, Gandak, Hirakunda, Nagarjuna Sagar, Chambal, Kosi, Damodar Valley, Mahi, Rajasthan Canal, Sri Ram Sagar, Sri Sailam, and Sada Sarovar. These were all related to the hydraulic dam construction. So by the dam construction, we were getting parallelly electricity, as well as we stored the water at the time of the rain, when we get the peak rain, and that stored water we use for the agriculture purpose. So because of the three major, at the time of the Green Revolution, 3 sectors played very important role. One was that we constructed a huge channel of the irrigation system across the area where the Green Revolution succeed. We introduced high yielding variety, and we introduced fertilizer application optimally. So these three, what you can say, input are played very important role for the success of the green revolution. Not only the variety, but simultaneously, if you see that the time of the green revolution, government constructed many channels of the irrigation also. So some of the programs also launched during that time, 1973 and 74. We can see here the programs like drought-prone area program, drought-prone area program. This and launched the time it was launched 1973-74, and this tackle a special problem faced by those fragile areas which are constantly affected by the drought. We delineated and some of the area those are constantly affected by drought. So this program we launched for that area in 1974, and these areas are characterized by the large human and cattle population which are continuously putting heavy pressure on already fragile natural resources based on for food and fiber and fuel. So those area frequently was facing frequently the drought problem. So they started to develop some construct the water harvesting or any structures, so that the population it was increasing in that area and cattle population was simultaneously that was increasing. So because of that, if that program was not initiated, because of that population increment of both human and cattle, they were creating a pressure over the fragile natural resources, because when the population of cattle will increase, so finally where it will go, it will range or it will graze, or it will depend on the natural resource. So definitely what will happen, the vegetation of that area will be depleted. So different maybe the programs have been taken during that time. Just the major problem was like continuously depletion of vegetative cover. What the government found that at that time, that the area was facing the vegetation depletion. So when the area will expose, that will be more vulnerable for the wind erosion, increasing in the soil, as I mentioned here, fall in the groundwater table due to the continuous vegetation without any force recharge under groundwater cooper. So they noticed at that time that because of the population increase of both cattle and human population in these drought-prone area, they were exploiting now the resources. So government given more emphasis to this area for the water development point of view. After that, command area development and water management program is started. And this program was totally, you can see, centrally sponsored plan scheme implemented in 1976 and 77. And the vision of command area development is to reduce the gap between the irrigation potential created and that utilized by the construction of on-farm development works like construction of field channel, field drain. So main vision of this command area development was at that time that we created potential, we stored water, but at the farm level, the utilization was very less. So because of this mismatch, they noticed at that time. So that time they want to minimize the gap. The amount of construction work happened. So the effect of that constructed dams or reservoir should be also maximized. For reducing that gap, they started command area development and water management program. So here you can say judicious and equitable distribution of available water, irrigation water, with active involvement of the farmers through the participatory irrigation management. So that is why they given more emphasis at the ground root level, means at a farmers level, that how we can distribute this water uniformly, optimally, and with more water use efficiency at a farm level. So that's why they involved to farmers also in this scheme. And here you can see the aim and objective was to bridge the gap between the irrigation potential created and utilized, I told, to ensure timely and equitable distribution of irrigation water in the command, to enhance the irrigated area by means of efficient water management. Definitely when the water use efficiency will increase, then irrigated area will increase. To boost agriculture production and productivity in the command, and to involve the beneficiary farmer at the grassroots level for management of water resource through participatory irrigation management and organization of Pani Panchayat. These were some of the aim and objective of this command area. So the evolution made in the past revealed that the CAD program made positive impact on various important indicators, and we found that when we implemented this program, this was success of. You can see the success like increase in irrigated area increase, productivity in production also increase, efficiency also increase. So, and apart from that also, despite the effort of efficient irrigation and water management, the problem of water logging has surfaced in many irrigated commands. So you can see, if you go in Haryana, as I told you now, you will find many areas that are waterlogged area. And because why? Because most of that area in near to Punjab and Haryana, they are irrigating maximum from the canal. And because of canal seepage, they are now facing the problem of waterlogging. So some of the problem also generated during that time that they noticed that waterlogged area also increased. After that, national water policy, we can see the Ministry of Water Resource, Government of India, to govern the planning and development of water resource and their optimum utilization. The first national water policy was adopted in 1987, and it was revised, updated in 2002 and in 12. So major provision that were undertaken in this policy are envisages to establish a standardized national information system with a network of data bank and database. These were the first provision. Resource planning and recycling for providing maximum availability. So when you are having maximum database of the water resource, and then you can plan your water, how you can allocate that water optimally to the different sectors. To give importance to the impact of project on human settlement and environment, guideline for the safety of storage, dam and other water related structures. Suppose previously when national water policy come, at the time it was also given importance that if you are constructing any water dam or any reservoir, so nearby the village, nearby the people those are settled there, means living there, you should also give their what are the safety procedures, what are the maybe because construction of dam is also very dangerous, because suppose if you are constructing any dam in any particular area, so there so what happens sometime water table increases and waterlogged area develop, and apart from that sometimes suppose the water dam broken, so instantly there will be the submergence of the whole area. So what are the safety guidelines are taken that were given more emphasis in the national water policy, that you must, if you are planning for any construction of a dam, you must include some what are the, you have to show the what are the safety procedures you are involving in this water policy or construction of a dam, if you are planning to go for the construction of the any dam in an area. And setting water allocation priority in the following orders, and after that you need to prioritize the some of the water demanding area, like drinking would be the first. After that irrigation, means domestic is our first priority. Okay, if the water is remaining, then we will allow that water for the irrigation, got second priority, third is the hydropower, then navigation, then industry and other. So in this manner, whenever you will plan to allocate the water, your priority should be the first priority that you must assure 100% drinking water to the people. If you assure that 100% is now this much of the quantity of the water will fulfill the 100% water demand in the form of drinking for the people is over, then you need to consider irrigation is the second. So in this manner, they settle the point that whenever we will allocate the water, our allocation should be in this manner. Water rate for surface water and groundwater should be rationalized with due regard to the interest of the small and marginal farmer. So water rate for surface and groundwater means pricing of the water, that should be very rational. Either if you are fixing the price for the surface water or groundwater, that should be the very much rational for the marginal and small farmer. So these were the points that were very important in the national water policy. When it was revised in 2012 here, the main emphasis when it was revised in 2012, now the water will be treated as an economic good, which the ministry claimed to promote its conservation and efficiency. Previously, in other policy, what was existing before 2012, we were not considering water as an economic good. But when the policy was formulated in 2012, then we start to consider water as a economic good. Okay, na? So that promotes, when definitely when it will be considered as economic goods, then we will consider it as a conservation as well as its efficient use. This provision intended for privatization of water delivery services is being criticized from various quarters. So whenever you will consider it is a economic goods, so definitely privatization, private players will play a major role. Then it was criticized at that time that if the water will go in the hand of the private people, so they may exploit us, and they may. So there were many complaints, and that policy was criticized also at that time. The policy also does away with the priorities of the water allocation mentioned in 1987-2002 version of the policy. The policy was adopted with a disapproval from the many states. And it was also found that when the policy that was formulated in 2012 was many points, this was deviated from those policy, national water policy we formulated in 1987 and 2002. That is why it was disapproved by the many states, because water is not a just issue of a one center policy. Here many states play a very important role. That's why tribunals are made for this to resolve the water issues in between the two states. And the main feature was of this, you can say, 2012 national water policy to ensure access to a minimum quantity of potable water for essential health, hygiene to all the citizens, available within easy reachable to the household. This policy was planning to ensure minimum quantity of water that is required for individual, for all citizens, that are essential to maintain their health and hygiene. And second was to curtail the subsidy to agriculture electricity users. This is still so far very problematic and a very big issue for the farmers of the Punjab. Governments used to change in the Punjab. If the politician is talking about that, they will curtail the subsidy over the electricity for the agriculture use. At the time of the Green Revolution, electricity was free in Punjab, and that was given to enhance the productivity of the farm. And that because of that mistakes of the government, so far the electricity is free in Punjab, highly subsidized electricity in the Punjab, and that is why they are exploiting too much of the groundwater. They used to open the tube wells in night, and whole night that tube wells will run on by the electricity and irrigate the field. So that is very exploitative. So that here, what the government thought that we should curtail some subsidy over the agricultural electricity user, and that was even criticized. That's why I'm saying that many things that were debated in these features. That's why this policy was criticized by many states. Then it was willing to set up some water regulatory authority. So to keep aside a portion of the river flow to meet the ecological need, and to ensure that the low and high flow release corresponding in time closely to the natural flow regime. Correspond to the in the time closely to the natural flow regime. And it was also pointed out in that policy that we need to assure minimum amount of the water that is very much required for a river to flow throughout the year, so that what vegetations that are depending upon that rivers in the side by the rivers, or even some biota and fish and other animals, those are side by that, means ecological setup that were developed over thousands years or hundred of the years, that should be not compromised just by the exploitation of man's water from the river. So government try to minimize try to assure the minimum flow and optimum flow during the whole period. So that point was also kept in this national water policy in 2012. And to give the statutory power to the water user association to maintain the distribution system. This policy want to give some power water user association, they want to maintain and give the power that they can maintain the distribution of the water in a particular area. Project benefited family to be the part of the cost of settlement and rehabilitation of the project affected family. And those family, though, will get the benefit, they have to pay the price and rehabilitate cost of, the project benefited families to bear the part of cost of resettlement and rehabilitation of the project. So if suppose any construction happen because of the irrigation development, so the cost those are occurring, the family will have to bear. Okay, now, so this was also point to remove the large disparity between the stipulation of water supply in urban area and in rural area. So those disparity that were existed at that time between the rural and urban area, especially for the water, that was also minimized. Given the point that we should minimize the gap in between the rural and urban water demand. And this policy supported the National Water Framework Law. Okay. So this policy got many critics. You can see here the paradigm shift in approach from service provider of water to facilitator of the service. Because of this policy, it was shift that now the government becomes service provider of the water to the facilitator. Now they are only facilitating, they are not taking whole responsibility. This was some time of the criticism happened with the policy does not deter use among those who can afford to pay for the water. Means there was no any limit. If you are able to pay, then you can use as much as. So this kind of some negativity was there, because so far still is this time also many metro mega cities, they are facing the problem because some are very rich and they are using the water for the recreation of too much, because they are having their own private ponds and like that. So at that time in the 2012 national policy, there was no provision that we can put a bar and limit for an individual that this would be your limit of the water purchase. PPP mode may not ensure equity, so they consider that those are criticized that PPP public-private policy is not a this will not ensure a equitable distribution of the resources. The policy does not follow polluter pay principle. Rather, it gives the incentive for effluent treatment. And one thing was that in this policy, they started to give the incentive for the wastewater treatment. They were not imposing any penalty for the companies or for industry that those were paying, those are polluting the water. Instead of that, they were giving just an incentive. If suppose a industry polluting the water, the government was not penalizing that a company that you are polluting the water, you should be penalized for that. Instead of that, the government was giving to incentive to the A industry that you should settle some effluent treatment. So this type of some of the loopholes were there. Policy was criticized for terming water as an economic good. So, and even many, they criticize that we cannot consider water as an economic good if you are considering it again, because many welfare activities, those are associated with the water. So how much it is time now? We can open for the Q&A. I think the 10 to 15 minutes we can take in the Q&A. So I told you now, there is the River Board Act also. In 1956, they have settled. The purpose of this River Board Act was, you can see, the act provides for the establishment of river board for regulation and development of interstate river and river valley, empowers the central government. And this River Board Act, actually this was the power was empowered to central government, and the main purpose of, if suppose any development activity you are taking, and definitely if you are constructing any canal, any rivers, definitely that will be a issue of the 2 or 3 states. So they have made a some River Board Act. So that through that they will resolve the different issue. Advising the government, that will advise the government interested on the construction, control, optimizing utilization of the water resources of the interstate, promotion and operation of schemes for irrigation, water supply or drainage, promotion and operation of schemes for development of hydroelectricity, promotion of schemes like flood control, navigation, soil erosion, interstate pollution of water of interstate river, and such matter may be discussed. So if any matter, what I told you, either in detail, electricity development or irrigation development or any pollution, flood control, any plan, activity, if the government is interested to take, then this act, through this act, they must have to advise the government. So preparing the schemes, including multi-purpose scheme for the regulating the developing the interstate river and river valley, advising the government interest to undertake the measure for executing the schemes prepared by the board, allocating on the among the government interest the cost of the executing any scheme prepared by the board, and maintaining any work undertaken in the execution of the scheme, watching the progress measure undertaken by the government interested. So these were the many act that was done under this your River Board Act 1956. And this was the, maybe knowing that in the Rajasthan, mainly benefited state is the Rajasthan. You can see Indira Gandhi Canal was constructed, and source is Hari Barrage, that is confluence of Satluj and Bees, where these 2 rivers are confluence, from where one canal was constructed, and location is Punjab, Haryana, Rajasthan, and discharge is 138 cubic meter per second, and the engineer was Kanwar Sen. Those in 1940s, he constructed this canal, and you can see the basin 20,000 square kilometer, and this was the part of 1960 Indus Water Treaty. So at the time it was constructed. After that, the accelerated irrigation benefit program was also started 1996-97, and this is the extension loan assisted to the state for the completion of irrigation scheme. Those schemes are not completed by the state government, so center wants that we should provide some loan to the state so that they can complete the irrigation project. So that program was called accelerated irrigation benefit program. And here you can see it was here. Accelerated irrigation benefit program was especially started because a large number of the river and valley projects, both major and minor, have spilled from the plan to plan, and mainly because of the financial constraint of the state government. Government started to realize that many states are not able to complete the major and medium irrigation project because of the financial constraints. So government started to give some loan amount, and some of these projects were in an advanced stage of the construction and could provide irrigation benefit in 4 and 5 agriculture seasons. The completion of this project, however, was beyond the resource capability of the state government, and it was also found that many of the state projects that were at an advanced stage, only maybe 1 or 4, 2, 4, 5 agriculture season, if that loan were given, and they can be at a that project can start to work. So for accelerating for that purpose, the government, central government start to provide the loan to the state government, that you should complete immediately. And performance, you can see the assistance provided was entirely in the form of loan in the beginning, but later a grant component was also added in 2005. The central support was further relaxed in 2006 for special category state like drought-prone area program, and some tribal areas and flood-prone areas like Koraput and this. So when East was started to provide the grant to the state, it was totally in the form of loan. But again, in the some grants were also added in 2005, and those states those are having a problem for the drought and flood and tribal area, that were also given relaxation in this scheme. So constant, this scheme could not succeed in its objective because creating irrigation potential and making it actually delivery are two different things. Actually, this scheme was not succeed at that time, and the CAG, you can see here, and PAC reports, we found that this scheme has neither achieved desired result nor was saved from the irregularity. In fact, 2011, PAC reported called a big scam, bigger than many others. So it was finally come in the form of a scam. Our reason of failure was that the scheme easily fall prey to the glaring beneficiary and irregularity, resulting into time and cost overrun. The key reason is that why both CAD and command area development and AIBP scheme failed to deliver is that work is confined to the construction of the main canal. Unless distributive network is properly in place, the main canal is useless. So the poor planning and lack of proper monitoring by the Central Water Resource Ministry has been the main reason for the underachievement. Mainly, the beneficiary, we not given in this scheme that how much construction and development work we are doing at the beneficiary level. Even though we constructed canal, but if the means channels are not developed at a farm level, so it is useless. And how it is happened? Because Central Water Resource Ministry has not at the time monitored these things properly. That's why. And recently, you maybe know that the Har Khet Ko Pani, Pradhan Mantri's Kisi Sinchai Yojana, and this is the Cabinet Committee on Economic Affairs chaired by the Honorable Prime Minister. Pradhan Mantri Kisi Sinchai Yojana, that is the started in 2015. So purpose of this to Har Khet Ko Pani, and this is the amalgamation, means many schemes now you can see here are clubbed together in this scheme. Those are previously running by the different ministries were clubbed together. Here 4 programs are clubbed, like Accelerated Irrigation Benefit Program, what we discussed. Ministry of Water Resource, it was running. This was also merged in this Pradhan Mantri Kisi Sinchai Yojana. River Development and Ganga Rejuvenation, this was also merged. Integrated Watershed Management Program of Department of Land Resource, this was also merged. On-farm Water Management of Department of Agriculture, these were the merged. 4 programs merged, that's why, and this that's called your Pradhan Mantri Kisi Sinchai Yojana. And objective was to conserve conversion of investment in irrigation at a field level. Here we given emphasis on field level, means farmers field level. Expand cultivable area under assured irrigation, improve on-farm water use efficiency, enhance adoption of precision irrigation, and even apart from that, recharge of the aquifer also we have given emphasis here. So management as well as the conservation, 2 component, and this main focus was on source creation, distribution management, field application, and extension activities. So leave it. These were all about the after that Jal Kranti. This is for the for the Ganga pollutions, means this is related to pollution, so we will not cover that. Before that, what I told you, all were related to your irrigation. So now this is the over. If you are still having any queries, you may ask. 8 minutes, 10 minutes we will give for the Q&A.
Yes, definitely. Among the participants, if anybody having any query, they can ask, please.
You must do some Q&A, because without Q&A, it is nothing.
One question is there, sir.
Yeah.
What type of irrigation it is when we give irrigation to crop in frost or intensive rainfall to increase temperature of soil?
What? I'm not able to understand. Yeah, it is in message box.
Yes. You please check
Yeah.
chat box.
It is what type of irrigation? It is when we give irrigation to crop in frost or intensive rainfall to increase the temperature of soil microclimate. Okay, dear, it is depend even on your what I told you now, in the availability of water. If you are having a sufficient amount of the water, if your area is facing the problem of frost, so at that time, surface irrigation is the best. Why? When the water quantity will increase in your field, as much as water quantity will be more in your field, because of a specific heat of water is 1. So it is always greater than soil. So there will be the less changes in temperature when the temperature will down in your area. So surface is the best irrigation. You can do that.
Next, anybody? Lokesh, you want to ask something?
Hello, sir.
Yeah.
Sir, I have no doubt regarding this today's subject.
Okay.
I want to know one thing about sir, exam related topics, sir.
Oh, tell.
Sir, what is the recruitment procedure for SMSs and KVK, sir?
Okay, KVK actually run by state government as well as the central government. Central government means those are sponsored by the ICAR. Okay. If the hello.
Yes, sir. Yes, sir. Yes, sir.
If that is by the ICR, then it will be recruited by the ASRB. Okay.
Yes, sir.
You listen now. And if it is run by your state department, means university,
yes,
so
sir.
that recruitment will be done by your particular university.
Yes,
and
sir.
beside these two, sometimes NGOs also work KVKs. Okay, na? So if you are interested to go in that NGO also, so those who will be the chairman and body of that, they will recruit you. Clear?
One question is there: how water potential is calculated in different parts of plant and in soil?
Yeah, tensiometer, you may be knowing that is a very pressure plate apparatus, and electrical resistance, TDR. These are the tools that you can use in the for the soil, and for the plant. I am forgetting the name of the instruments. Those are used for the measuring the water potential of leaf, or that. So I am forgetting that name. But for the soil water potential, you can use the tensiometer, more commonly used, and pressure plate apparatus, that is laboratory methods. And after that, electrical resistance method, gypsum block, and all that. Hope it is clear.
Hello, sir.
Yeah.
Yes, sir. Yes, sir. In case of central government, how they will recruit? Is there any exam or a direct interview? What I'm asking. That's
Okay. Your intention was actually so far, no, I am not gone across the notification related to the KVKs recruitment. Maybe, but definitely I will. You have given me the topic. I will try to make it in a video and will upload definitely on that. my YouTube
Okay.
channel. Okay, dear. Na?
Okay, sir. Okay, sir.
Okay,
Thank you.
dear.
Okay, sir.
One more question is regarding important points regarding ancient irrigation techniques.
Dear, at the time of ancient irrigation system, you might be seen in my slide that at the time, main emphasis was at the time the rulers given for the construction of either dam means storage, and channel they constructed. Okay, na? At the time that the time was not much advanced, so they use surface as a source of irrigation. So in the surface method, as a channel, furrow, they were using at the time. So, and those are modernized irrigation, like now we're talking about the precision irrigation, drip irrigation, sprinkler irrigation. These were all the modern techniques. It was not happened during that time. At that ancient time, mainly rulers were giving emphasis on the water harvesting construction. If you go in the Rajasthan or any area that were ruled by the any king, so you may see that they constructed reservoir. Even if I'm seeing, I'm giving you the example of Hussain Sagar in Hyderabad, Sundar Sagar, given the Chandragupta were given. So they constructed water reservoir. And through that water reservoir, they were applying the water through the different channels and like that. This type of the development were there at the time. Surface irrigation, what you can say. Any questions? Other question?
Any other?
Sir, what is cobligation and corrugation?
Cobligation and corrugation. Actually, tomorrow is that this is that you will learn the method of irrigation tomorrow.
Yes, yes.
Okay,
yes,
na?
yes. Tomorrow
So
we
don't
will
worry
see.
about the types of irrigation. Even you ask that, then I will tell you. Search irrigation is, suppose you are having different rows. So in the intermittently you will apply the water to the different your furrows. In cobligations, there is one pipe under that the system they have. So they will just pull that system, and that when that will proceed again and again, and the your pipe will be open for a particular furrows. So I will tell you in the pictures form tomorrow, because tomorrow is also I'm having so methods of irrigation I will tell you. So I will show you what is that. Okay, na?
Sure, sure.
Don't worry about that.
One question is there regarding does GC of water affect potential of water?
Yeah. EC means क्या होता है? EC means यही होता है soluble salt concentration, how much it is there in your. If the your EC is what saline and alkaline. In this case, saline case, you will find the EC more than 0.4. Okay, means when soluble salt concentration is more, so that is not issue. But if the EC is less, okay, and so it means that soluble salt concentration will, when it will decrease, then it will be problematic for your crops. So reverse osmosis will happen in your field. Like if saline soil, if I'm talking, in that case, your soluble salt concentration is less as compared to saline. So that is why in saline alkaline soil, plants show wilting symptom. Water will start to flow reverse. Okay.
I think there is no more questions. Mr. Gule, please conclude one question. Why water potential in soil is higher than the root or leaf?
Why water potential in soil is higher than that of root and leaf? Do water potential depends only on pressure, gravity, and solute? What I told you, first of all, you have to understand what are the components of soil water potential. I told you, in soil water potential is a component that will have a component of osmotic or metric potential, your gravitational potential, pressure potential. Okay. So in the case of soil, when the water is when the water is what I can say, when water is more, because you are irrigating the field, you are directly pouring the water in the field. So when the water content will increase, so that will increase your water potential till the moment it reaches to the hygroscopic potential. Hygroscopic, when you will when the water will lost either in the form of absorbed by the plant or evaporated by the soil, then in the soil also pressure, water potential will go down. In drier case, if I am talking about a dry soil have highly negative water potential than your plant's roots and what you are saying, leaf. So that is why now the plants not survive in the case of dry soil. Only because of you are knowing that pure water is having highest water potential, 0. When you are adding in the soil, at that case, the water potential of soil will increase. Previously, it was negative. Why you are going to apply the irrigation? Because you are going to increase the water potential of soil so that water will continuously flow from soil to root, root to stem, stems to leaf, leaf to... So you want to be, the system should be continuous. That is why you are pouring the water. No? Because of the application of the water potential in the case of soil is higher. Hope you got.
Yes. Anybody? So I think there is no more questions. Nana sir, please conclude this session.
Okay. We are very much thankful to you, sir. It was a very informative and conceptual lecture from exam point of view. Actually, students are always feel it is very difficult, but you have taught this very nicely. In that you describe the irrigation, its need, supplemental irrigation, deficit irrigation, concepts of irrigation, then water potential, and it was very nice, and you explained very deeply. Then osmosis, metric potential, gravitational potential, then pressure potential. Then you have also explained the importance of water potential, irrigation development, then pattern of water use, water resources development in India, then Indian river system. In that you explained Himalayan river system, Ganga river system, Brahmaputra river system, then peninsular rivers, in that Narmada basin, Godavari basin, Krishna basin, Kaveri basin. You also explained irrigation development in India, in that drought prone area program, then command area development and water management program and its aim and objective, and finally also explained National Water Policy 2012, then the River Boards Acts. So thank you so much, sir, once again for your knowledgeable lecture and spending your valuable time with us. Thank you so much, sir.
Thank you. We'll meet tomorrow.
Yes, sir. Okay. Thank you.
May I leave now? No?
You can leave now.